Good morning, Wonder Women of the World. I am Ilona Budapesti, Chief Storyteller of 1 Million Women to Tech.
Good morning, Wonder Women of the World. I'm Frederick Castor. I'm the Chief Mentor. It's my first day on air, and I'm super excited. I hope you are as well.
We are broadcasting to you live from San Jose, California, from 6:15 a.m. to 7 a.m. Monday through Friday every other week during Winter of Data. Because we only have 45 minutes, let's get started. I'm going to share my screen right away. Actually, probably like this. All right. Can I get a quick thumbs up from you VIP and Gold members if you see Exploratory data analysis? So here's our roadmap. What we're trying to achieve here in this roadmap is through these 5 topics: Exploratory data analysis, descriptive statistics, estimation, hypothesis testing, and design of experiments, to give you a feel of what you would go through the whole process in a work environment if you were a data scientist, and to give you some intuition of what it takes to go from a data set to actual application. Awesome, people can see us, great. Can we talk about, Fred, a little bit of what we will not really touch upon, or we will mention it, but it won't have its own unit itself?
Yeah, so there's a bit of an overlap generally between data science and machine learning. Machine learning often uses very similar techniques, but it's a bit more an engineering perspective. Sometimes it uses very fancy nonlinear techniques, which are very good if you have loads and loads of data, but not always the best if you have relatively small data sets. So we will not go into detail on things like deep learning or SVMs. And these are partially covered in the Summer of Code. So if you're interested about that, then wait until the summer or rewatch the videos of last Summer of Code. There's quite a bit on that. We will not talk about very fancy regression analysis. We will not talk about Bayesian data analysis, which is a very interesting alternative view about how you can think about making estimations in a probabilistic way. So to get an idea of how uncertain you are about your knowledge of the world. That's very interesting. It's just...
We will go into more definitions later. It's just giving you the keywords so that if you are Googling or self-teaching, you have an idea of where to focus.
And we will not go into detail on time series analysis. So there's a special set of techniques for processes that change over time, things like temperature. It's very often used for economic modeling. Again, that would be probably a lecture series in its own right. So this is currently out of scope.
Fantastic. I just wanted to give a shout out to everybody who's watching. Yulia Pachkovska, Katie Zid, Bushra Shaheen, Anika Shestra, hello. Please put your questions in the Facebook comment and we will incorporate it as best as we can. I would say let's get started with our first data set, because we have given you a data set from the 1954 Berkeley Growth Study. This is a growth study that followed children for 18 years, girls and boys, and measure their heights. And so we have a data set for you in CSV format, but we didn't want to quite demo on that because the homework and the certification quizzes are based on that. So what we will do instead is we'll make up our own data set, a synthetic one.
And since we're in California, which is home to the famous Sequoia National Park, we decided we'll make our data sets for sequoia trees.
Okay, so let's get started. In order to be able to plot things, I'm in Jupyter Notebook using Python 3. And you can see that actually, let me just narrow it here. You can see I'm using Python 3 here. I also have access to JavaScript, which I will show you during the later parts of the week. But today we'll stay with this. So matplot.
If you have Python 2 only installed on your computer, I'm pretty sure that all the examples we're going to show should also work for you.
What happened on the, look.
Oh.
Uh-oh, that's not good. Let me just redo the screen sharing. Sorry,
Seem to have a little technical glitch with our screen sharing.
That's better.
There's a little delay there, so.
Yes, let's hold. Okay, so matplotlib inline, which makes sure that we can actually show you the plots instead of saving just into a file somewhere. Oh, that's much better.
Oh,
yes, good. You see my screen now. Excellent. If you are watching on Facebook, can you please give a little B for thumbs up if you see the screen? Just little B, it looks like a thumbs up. Fantastic. Yofia says. Let's continue. So now what we need is to use some libraries. We're not going to actually write this from scratch. So Fred, which library shall we use?
So in this case, we can start with the NumPy library, which is used often for all kinds of numerical operations, numerical analysis methods. And then later we will also use the pandas library, which is very good for what we are showing this week: exploratory data analysis, graphing data, computing simple statistics, all kind of that. Yes.
That's important. How many Sequoia trees would you like, ladies? Please type in the chat. You can have a choice between, let's say, 15 to 25. Much less, and we won't see anything. Much more, and it will be a bit too messy. So I need a number. Okay, Tick said 20. She was the first one. We'll have 20 trees. Excellent. Let's have some labels.
Yeah. So we need a first column, which we will call. These are the column labels. So pandas, the library we're going to use later, is sort of a row column oriented format, like in a spreadsheet. So we have a first label that we call H, and then we can just call them, let's say, tree, or just call them 0, 1 to 20 to keep it easy.
Zero to D?
To D. This just means we format numbers so that they all have 2 digits, even if it's something like 1. That will be
0, 1. Sorry, I.
Exactly for I in range from 1 to n plus 1. So Python has this little, as many programming languages, has this property that by default everything starts from 0. Here we start from 1. That doesn't really matter.
That's very kind. Okay, and now what we need is also the length.
The data. No, this is the data itself. So again, we write the data row by row. So the first column will always contain the age. So let's start with 100 years. Sequoias, that's a baby for a sequoia. And then we can write something, we can just write some random data.
And we receive this randomness for free from the NumPy library, right?
Exactly.
Excellent. And we
let's
want
say
to
times 10 plus 20.
So that will give us a random number between 0 to 10.
So if we look at the NP random rand n, this creates n random numbers between 0 and 1. So we scale them by a factor of 10, and then we add 20. So this gives us random numbers n. So in this case, 20 random numbers between 20 and 30.
Okay. So ladies, this is a great thing to practice with and break when you are in your own Jupyter notebook. I think we had a little random number generation and transformation in, I'm trying to think if it was in week 2 or week 3 of Summer of Code.
Okay.
Okay, that's it. And then let's save this to a file, shall we?
Mm-hmm.
Oops.
So far it's okay.
It's okay. Okay.
So this with statement means it automatically opens the file and then closes it again once we are done. So we call
It's
that,
hard to spell sequoias, to be honest. Okay, CSV.
next time we just use pines or oaks.
Okay, CSV file. If you are, how many of you are familiar with CSV? If you are, can you just type in a little Y? And if this is new for you, then type a little N, whether I should talk about it or not. Please repeat the title of the current topic. The title of the current topic is Exploratory Data Analysis. And right now, we are generating a synthetic data set that's a little similar to the data set in your homework so that you can work on it. No, okay. So CSV stands for comma separated values, and we will then take a quick look at what it looks like. It's basically simple text with commas in between showing that they are different columns. And then each row is also delimited by a new line. So it's human readable. It looks like a spreadsheet. You can use Excel as well, even to open it. And it's a very common data format when you import, export, or just use data. Okay, so we need to write this file.
We open this file for writing.
This we did actually the file input output in week 2 of Summer of Code.
So we give it a identifier f_out, for instance.
Okay.
Okay. Then,
And let's print it. So print.
So
We need to join them. Oh, sorry.
dot join.
Dot join.
So we write everything to a string for x and labels, and then file equals f_out. May I just ask, is anybody who doesn't have Python 3 who just has Python 2 on their system?
I saw one post here that said, could you please also share Python 2?
Can I just share what this would look like in, so let me just make a command line here. Okay, so this is a comment, so this will not be in our code, but you just take out the hash at the beginning if you're having Python 2. Everything else should work the same for you, but the print is a little bit different. It would look like this. Print, then you have these 2 chevrons, f_out, and then you basically have the same as we have here. So if you're using Python 2, you use this upper line, this line here. Yep. And otherwise you use, let's just put in a hash again that doesn't confuse our code, and otherwise you're using the bottom line.
I'll do this one. Excellent. Okay, and then we write also, I just want to put some speed on it because it's 6:30, and I would like to show them the data set so people can start playing with the growth.
So this writes basically our labels, our column labels, and we print our first line. So we string x for x in L, again file equals f_out. So now we have written the first, the labels and the heights of the trees for when they're 100 years old. And what we want to do now is we want to, let's say, plot there, generate a new height every 100 years.
From 200 years. Okay, I need an upper limit, ladies. I think sequoias can be as old as
3,000 years.
3,000 years, but maybe we don't have to go. So I need an upper limit for how old you want the sequoias to be. In the Berkeley study, the data set that you get, it's between, oh, I can't tell you. That's a spoiler. Okay, so I can't tell you how far the data set goes, but it certainly doesn't go to 3,000 years. 1,000? Yeah. We can be a bit more generous than that. Naringa? Regales is just 1,000? 2,900. Okay, Sabina Wong has spoken. Okay, 2,900, and we'll go every 100 years. Okay. Fantastic. Okay, so new line equals.
So then we still give the h as the as a row label basically, and then we.
This notation of the brackets comes from Python itself, or is it a NumPy thing? Or
It's Python. It's a list. So I create a list.
I see.
So and then what we do is we create for each of them we create a random number between 0 and 1.
Right. Sorry. Between 0 and 1.
No, random dot rand.
Random dot rand.
And then in 0 brackets plus x for x in L1. So let's just explain that. So we don't want our trees to shrink. We just want them to grow. So we take the previous line. We discard the first element. So we start from the second element. Again, that's in Python. If we have it 1 here, we start from the second element. So without the h, for every element, for every height we had in the previous line, we add a random number, a single random number between 0 and 4. So on average, we say they grow 2 meters every 100 years. I didn't know if this is true for real sequoias. It's just something that looked nice for us.
Yes. This is something, if you watch the 2-minute daily data this morning, actually, might be interesting, is to create your synthetic data set of people and number of arms, for example. So this is an example here where we're doing it for a growth data set. Okay, 1,113, 1,999, 115. Okay, Katie, Irina, Asam, Regina, Galambos, Neringa, you can choose your own. It's excellent.
Yes, exactly.
Okay, and now we just...
we print this out, open the file.
Let's join these.
So L for L in new L. Again, file equals file out.
Do we have a bracket somewhere wrong? Yeah.
This goes here.
Thank you.
And
Yes,
we don't need the
you
second one. And again, if you're using Python 2, shall we share how basically everywhere where there's print and we have this print opening parentheses, then something, then file equals file out, you would have print, then these two chevrons held, and then what we would be having before this.
I think it's enough if we show it once, because
okay.
I mentioned that we will be demoing in Python 3.
Right, just to make sure it's...
Okay, ladies, are you ready? Let's run this, and then what we need is to see if our new height sequoias 1.csv has been generated or not. Okay.
It's always an interesting question. Did the code work?
Yes. I do see a height sequoias here.
It was created at 6:35.
It's at 6:35 a.m. We did not cheat. Excellent. So let's very quickly open it up and
Excel, for instance, or you can just use it in text editor.
I would like to open it in Sublime, actually. Okay. Where's my... Okay.
And also print the content of the file in Python itself.
Yeah. So here we look at it. It's human readable, and we have the first row. This is the...
These are the column labels. So we just called the trees 01, 02, 03, and so on. And then the first column is the age column. And then the second row shows, okay, the age is 100, and then it shows the height of each tree. So the first tree, 01, has a height of 25.9, and so on.
How did we show it in Jupyter Notebook?
Right, so in Jupyter Notebook, we can print out the file, but there are actually some much nicer tools.
So let's do that. And I think then we need to put some speed on it so that we can...
So we now introduce the pandas library, which is very good for this kind of exploratory data analysis. Import pandas or import pandas SPD, which is what people usually do because they don't like to type. So you could execute this. All right.
Yes, now it's good.
So, okay, then we give it the file name. fn equals, in this case, heights sequoias1.csv.
Oh, I really don't like typing.
We can just copy and paste.
Sequoias1.
Yeah.
CSV, okay.
And then we write something like df equals pd.read CSV. So this pandas
DataFrame.
library has, then we give it the file name, and we first, and we can also tell it where to take its index column.
So let's talk about this for 1 second. Pandas allows us to take a CSV file. Ladies, this is really awesome because normally when we did week 1 or week 2, I wouldn't give you this type of library. We would just read in from a file, element by element, and make your own, for example, array of arrays or list of lists. So here, we get that for free and lots of convenience functions attached to it. And it's usually called a data frame because it looks like a frame.
Oh,
it's a spreadsheet.
We can look at it.
Let's look at it actually, yeah. So shall we just print it out? So if we do this, this is a good place to, for example, start playing in your own as well. So we get the spreadsheet right here.
So H is the index label, and then we have the different column labels 0, 1, 0, 2, and then we have the data as you would look at it in Excel, for instance.
So each tree is a column here, which I can't highlight.
Mm-hmm.
Why did you choose it to be a column as opposed to a row?
We could also have it the other way. This might have made more sense. To be honest, because I wanted to grow the trees over time. So basically every day we can use the last one. Might have made more sense actually to do it the other way around. Okay, ladies, that's a good homework for you, is flip the rows and the columns. You might need to consult the documentation a little bit so that you write, so the trees, so each tree is a row and they grow with time to the right. So here we have each column being a tree. Okay, quick quiz. Each tree is a column or a row right now. Please type in column or row. Bushra Shaheen says, what are the prerequisites for this learning? Bushra, there isn't too much prerequisite in the sense that the programming here, for the beginner level, we are not going to require you anything that we don't really demo. However, if you're intermediate or attending, or if you joined the Summer of Code already, I would say this is probably after week 1 and week 2 of Summer of Code and your own completing of the Python the hard way. So the Python introductory book. You can also do this. I will demo in JavaScript later in the week. I think I actually might have a JavaScript. Yeah, I'll just quickly show this. I have another Jupyter notebook here, and you will see up here, I hope you can see it, I have Node.js running. So if you have done the JavaScript week, which is week 5, you could also use it. And here we are allowed to type JavaScript directly into the console. Such as, for example, I was playing with the gender pay gap data. So let's see. The advantage of JavaScript is that it's interactive like this, versus with Python, it's not. Are we going to share the Python notebook after the video session? Buket Konukhurst says. Buket Konukhurst, I'm sharing this to the VIP and Gold members. I am not sharing this publicly, no, but you have all the code in front of you, so you can type it in. Can we find links to some Python programming that we use in this course? It would be really helpful. Yes, that we can do, definitely, absolutely. Great, Nadia, good question. All right, we have our code. Shall we plot these so that we can look at it? Actually, that's the, since the question was asked, why are the trees in the different columns and not in the different rows? This is because now something will work very easily. We can just say df plot. And now, and now we see that it works the way we want it to work. So we have H as the x-axis, and we have one different plot for every tree. And if we had done it the other way, and we just said DataFrame plot without anything else, then we would have the different tree labels on the different tree levels on the axis, and we would have a plot for each age, different plot for each age, which doesn't make much sense here. So this is why.
Okay.
This is the reason why I wanted to do it like that. And
one more question. I think we had 2,900. Oh, column. Excellent, VIPers. Very good. So we had 2,900 as the last age, but here we are stopped at 2,800. It looks like it's not inclusive. The last step is missing.
That is always like this in Python.
Okay, so if we wanted 2,900, as Sabine Wong said, then we actually would need to
2,901.
2,901 here. Okay, next time. Or I can just make it read.
If you want to retry it.
Yeah, that's really nice.
Yes,
oh, there it is.
Now I got it.
2009. Okay, I'm happier. And now put the label in a different place. Okay, that's something that you can, I guess, put parameters in here in the plot, right?
Yes, and now we can maybe show a couple of parameters that may be useful. For instance, in this case, the legend is not particularly useful because it's just
covering
1, 2, 3, 4, 5. If you have something later in the homework, you may have girls and boys and so on, so then the legend might be a bit shorter and a bit more informative. But here we can just turn it off. We can do this like this.
To answer the prerequisites, I assume that you are fairly good, for example, with Excel, but you don't have to be really very terribly good at programming. Because we're giving you all the functions and the code that you use. Okay.
So then in this case, it doesn't show us individual data points itself, it just joins them all up with lines. So something else we could do, for instance, is we can actually plot the data points themselves.
I'm not sure if they can see that low on the screen.
Okay, let's
yes,
again, we turn off the label, and then we can say style equals, and now what does this do? This means we actually have a little dot at each data point, which allows us to show, okay, we have the data evenly spaced, and we have one data point every 100 years. So excellent. This is something we lose if we don't have the individual data and just have them joined up like this.
For those of you who are data dragons, so you're planning to do this more than just an hour after the class, the way to dive into, or where would you get, how would you know these? You go actually to the pandas documentation, and you can read up on each function. It will explain what kind of parameters you can set, and you play with it. So this just shows you how to engage with a new library. Okay, can I get some thumbs up so far? We actually did a lot. We generated a whole data set. We saved it in a file. We read it back in, put it in a new data structure, and now we plotted it. And we're kind of massaging it to make it look like the way we want. Can I get some thumbs ups? If so far so good? Oh.
There's also an even simpler way. So you can look up the online documentation, which has many examples. Or you can also do something like, how can I get a new? You can write something. You have this in Python. You have this integrated help method.
Sorry, just lots of thumbs up. Sorry,
awesome.
Coming in. Awesome.
So whenever you're interested in a certain method like dfplot, you can write df help dfplot dot plot, and this gives you some.
Scroll up a little bit?
And this gives you an sort of online help, so an integrated help which tells you the name of the function. It tells you what kind of different parameters you can have. So you can have line plots, you can have bar plots, you can have histograms, box plots. We will talk about some of these plotting schemes. If you like pie plots, which...
Can I foreshadow a little bit of what the rest of the week will be? Because only the Monday class is open. And I'm happy to start taking questions as well. But we need to do two more things. One is we would need to talk a little bit about maximum, minimum, and mean.
Mm-hmm.
And the second is talk a little bit about visual intuition and what does it really mean to be exploring data visually. But before I do that, some of you are beginners. Some of you are quite progressed in your self-teaching and already maybe come from a numerical background or are very good with Excel. The idea in the real data set, so the Berkeley growth study, is that we would love for you, that we will be giving 3 levels of problem sets. The first one is really covering what we did today in a bit more detail. The intermediate one, however, Irina, I'm thinking of you, is actually asking you a little bit about, can I just say, I don't know how to say it without spoiling it, well, we'll talk about rate of change, right? Mm-hmm. And the interesting features within the data set. And if you're really advanced, we will actually ask you to consider creating smoothing that is not really available off the shelf. It's not written in Python per se, so you would need to write your own fitting functions. Mm-hmm. And explaining your choices and so on. So you can take it as simple as just reproducing this coding example that we're giving you here, or you can take it to really exploring the data set and
just looking up, maybe having to Google up a few things on the internet, or reading documentation of different libraries and thinking about it yourself.
Mm-hmm. But we can take this quite far if you want to challenge yourself. Oh, Irina gives us hearts. I know she loves challenges, to be honest. That's what motivates her. So Irina, to be honest with you, the first derivative is quite nice, but the second derivative actually is very noisy. You will see this. And having a meaningful discussion of that is quite advanced and is very interesting. Of course, there's girls in it, so I'm even more excited. So yeah, all right. The rest of the day, we have about 10 minutes left. Time for Q&A. Please throw out all your questions. Now is the time. It's live, you know. This is gonna go up on YouTube, but then it's going to be static. So now it's live. Start asking whatever you can. Frederick is a PhD in data science, well, image processing, really.
Machine learning, data science. I've been working in the field for a couple of years.
Well, like a decade.
After leaving university now, you tell everybody how old I am.
No, okay, just a couple of years. He's really, really, yes.
So I'm very, very excited about sharing this knowledge and getting more women to enter this field.
Yeah, he's original feminist, which is why he's our chief mentor. And if you've been to the Summer of Code, actually his work is in the week 4 introduction to AI, where we did a black box approach to using basic regression and the random forest fitting. So if you're interested in machine learning, that week 4 is a similar, like in 5 lectures, we just give you a black box approach to how to use it. Question. The other lessons are only available to the gold course people, right? That's correct. Is the gold course open already? Ladies, the gold course I am sharing with you via the gold email list and the gold Discord, because I'm still, it's a bit finicky with the website. So I'm planning to open the gold course access on Wednesday. But yes, you have access to it already. The GitHub is open, the GitHub Classroom, and this data set is open and ready for you. Is it accessible to beginners as a gold member too? Yes, it is. You would have to take this video step by step and very much copy and paste and just modify it using the documentation. VIP membership is completely not available at the moment, right? That's correct. We really want to make sure, because we have so little women power, we want to make sure that first we deliver for the existing gold members all the certificates that you know, they have already submitted the homework for. And then once we've caught up on ourselves, we will consider how can we create the capacity to open up more memberships. Okay, great question. Thank you, Sabine. Is it Sabine or Sabina? Can you type like a pronunciation guide for me, please? Okay, let's jump into
The assignment?
the assignment. Well, maximum, minimum, and mean. We need to talk about those, right? A little bit.
Not yet for the first day's assignment. That's for the second day's assignment.
Okay, so first day. Okay, so first day's assignment is simply to plot the boys and to plot the girls' data. So for example, if you have golden VIPers, I'm talking to you, in the GitHub Classroom, you have access to the data set. Okay, and if you have gone to the Classroom link, you got a copy of this repo here for you, which has yes, good. It should have 3 files in it. This hide sequoias is our first version of the Sequoia CSV. It's random. It has basically the same, not linear, but monotonously, strictly growing. Height. So the sequoia trees don't actually dip in height and then grow again. And then you have the height girls and the height boys, which are from the Berkeley growth set. So your homework for today, if you're complete beginner, is just to get the plots for the girls and then get the plot for the boys. And then look at what kind of curves and patterns you might see.
Can we go back to the plots we had?
Absolutely.
So we have a couple of questions that you should all be able to answer when you just look at the plots. So we ask, for instance, can you give us some examples about the typical heights, minimum, average, maximum of girls and boys at different ages? However, for that, the point is not yet that you have to actually calculate the minimum or the average. This is something we are going to show probably tomorrow. It's more like you look at the plot and say, okay, at 1500, the smallest tree is about 45 meters tall and the tallest tree is about 60 meters tall. Actually,
yes,
there's something else I can.
There's a good question in the meantime while Fred is typing. Nicole says, if we don't have access to this site, how do we submit homework? Excellent question. Nicole, first things first. For the complete beginner, I will open well, my hope is that I can debug this by Wednesday, and then you will be able to submit it through the course page. So it will be 1millionwomentotech.com/course/exploratory data science. For those of you who want to submit your code as well, it will have to be through GitHub. And for that, you will need to send a pull request into your own repo. I know that sounds complicated. Have you done Summer of Code with us, Nicole? Especially week 12, the GitHub was the greatest request. When you click that GitHub classroom link, you will get your own, it's not even a clone, it's your own private repo actually. Yes, like SOC. Is it okay if I demo, I don't know, Tick, may I take yours here? Just very briefly. So for example, you will have this GitHub Classroom, each of you have your own repo, and you will have a prefix appended by, I think, your GitHub username or your name. And then this is the repo to which you will push up. You don't need to fork it because it's your private one. So you can just push up to here. Open a branch and then send a pull request to your master branch. And let's keep in communication on Discord so that we can move forward. Also, Anusha has written a bot that actually is taking your PRs and notifying mentors. So we would love to, you know, work this out throughout the winter of data, because that way we will be able to scale to the mission of 1 million women in the end. Yeah. Okay, cool. Very good questions. So sorry, let me go back to the. So
one little trick I am showing you here as well is if you have this grid equals true option.
Oh, that's useful.
That's actually quite useful because so we'll ask you for some typical values, but the idea is not that you yet compute the real mean and the real minimum, but just look at the plot and say, okay, at the age of 1500, the minimum seems to be around 45, the maximum seems to be around 62 maybe, the average seems to be around 55.
Okay.
So just get a visual exploration. This is all about visually exploring these data.
Fantastic. So today's goal is just to plot it. Plot the basics. Oh, why am I showing that one? And my live video has. I lost you, ladies. Oh, there we are. Good. It's just to plot the Berkeley growth study, girls and boys separately. And as Fred said, when we send you the multiple choice questions, for example, can we give an example that's not in the question bank? Let's say, please tell us roughly what is the tallest girl, I don't know, at age 15. Okay, the point is not to go into the data set, into your raw data and look up the number and be like, okay, it's probably, I don't know, 137.5 centimeters, but because this is exploratory data science, these questions are just getting you to look at a graph and ballpark those numbers. Does it make sense? So how can let me ask something.
It doesn't have to be super precise.
It doesn't have to be super precise. It's more about your intuition. Okay, what range is this in? Where is the average, roughly? And so when we ask you these questions, we are trying to asking you to look at the graphs and answer the questions, not the raw data and the numbers. So when you're answering the multiple choice questions on Wednesday, will you be looking, please type in, will you be looking at your graph or will you be looking at the raw numbers? Type in.
Awesome.
Awesome, well done. Yeah, so that's the whole idea of the exploratory data science. And we will show you a few more data sets throughout the week that are, actually this is the creativity in this, isn't it? Is to find the right visual representation that shows you exciting, interesting, maybe strange things that need explanation. And that's where the skill comes in. It's not so, in this case, when we're doing exploration, it's not so much about calculating the mean, for example. Okay, so here are, I don't know, 2,000 numbers. What is the average? Graphs. Awesome. Ladies.
Lots of graphs.
Lots of graphs. Fantastic. Oh my gosh, this Facebook post is going to get hopefully a lot of a lot of love from the algorithm, because I think they bonus you for interaction. I didn't even think about that.
Awesome.
We'll A/B test it. One more thing, we talked a little bit about why we call this exploratory data science. I'm just going to stop the sharing. So, well done. You've done your first taste of exploratory data science. Actually, you probably have done things like this before if you've ever charted your height or your weight or your grades or your calories or anything like that. You have looked at patterns before and you were looking for interesting things. Or I don't know if Kamen is watching, but Kamen Lei, I know your partner is a huge Strava fan. Like, she bikes all the time, so I'm sure she has looked at a lot of her graphs. Why do we call this exploratory versus, it's a bit rough, but let's call the other two categories confirmatory data science And then let's call this third bucket predictive data science. So I think it makes sense to just describe a little bit of why we're starting with exploratory and what is the other option. So confirmatory and predictive. So let's talk about confirmatory a little bit, if possible.
Okay, so confirmatory is if you already have an hypothesis in mind. You say, okay, girls grow 3 times faster as boys or whatever. And you actually want to use your data to find out if this hypothesis is true or not. And I think we will talk about this in week 3 when we talk about hypothesis testing. And the other one, predictive data analysis, is quite close to what is often called machine learning these days, and what was explained during the Summer of Code, that we have certain variables and you want to, for instance, predict, I don't know, you know the location of your house, you know if it has a patio or not, if it how many bedrooms and bathrooms, and you want to predict how much is it going to be worth, for instance. This is something which is often used done with machine learning models these days. So these are 2 very important fields. But however, when I found it over and over in practice, whenever you are given a new data set, which you can get from the internet or from a customer, or which you could have measured yourself, it's often a good idea to first get a good qualitative understanding of these data so that you know what are typical ranges, what are oddities in these data, what is interesting or strange, has it been maybe censored or cut off in any ways, are there some outliers, is there anything that looks obviously wrong or at least unusual and worth of further investigation. So I think that's a very important technique and a very important attitude to develop, that you first, when you get some data,
I like that attitude.
Yeah. You sort of try to understand it for yourself as well as possible before throwing the heavy machinery at it.
Oh my gosh, Irina, hashtag data attitude.
Data attitude.
All right, ladies, wonderful. Please join me and please put out your right hand if you're watching this video in front of you. Yeah. Okay, excellent. Now put it over to the left of yourself, and now pat yourself on the shoulder. Well done. Congratulations. Thank you, Chief Mentor, for coming. Thank you for all the great questions. Your homework is to dig into your data set, either make your own Sequoia data set following the video and play with it, or if you have access, you can get the Berkeley Growth data set. Actually, you can find it online if you really want to follow along as a DIYer. And for Gold and VIPers, thank you so much for supporting Only 1 Million Women, and I'll see you tomorrow.
See you tomorrow, everybody.
Bye.